Hi boys, welcome to part 2 of the networks unit. Today we're going to briefly talk about matrix representations. So, graph can be represented by a table or an adjacency matrix, just like this, in which the numbers denote how many edges connect each pair of vertices. So what we're going to do is we're going to compare the graph below, or the network, and its associated adjacency matrix. So, what we do is we read it like a book where we go from left to right and from top to bottom. What we do is if we read it from here, so A is connected to A 2 times. Now remember that a loop counts as 2. A is connected to B also by 2 edges. So we have to draw 2 edges. A is connected to C with 1 edge. And then A is not connected to D. So you'll notice there's no line connecting A and D. From there, we just go down. So B is connected to A twice. Well, that's already done for us. B is not connected to B, so there is no loop present. B is connected to C once. B is connected to C. And B is not connected to D. Then we go to C. C is connected to A once. Already there. C is connected to B once. Already there. And you'll notice that the rest are zeros, so we don't have to worry about that. Let's do another couple of examples of this, and we'll do it both ways, where one we will fill in the table, the other one will actually create the network or the graph. So in this case, there's actually 5 vertices that we're going to have to go through. So let's just start at A. A, you'll notice, is connected to C twice, and that's it. So what we do is we put zeros into those gaps. Whoop. B is connected to C, connected to D, and you'll also notice that there is a loop present. And remember, a loop counts as 2 in an adjacency matrix. And I'm sorry that it keeps doing that, this presentation, but we're just going to have to put up with it. The other ones are going to act as zeros. When we're going to C, C is connected to A twice, so a 2 goes in there. And C is connected to B once. Oh, sorry. C is connected to D once. The other 2 are going to be zeros. D is connected to C. D is connected to B. And D is also connected to E, with the other 2 being zeros. And finally, E, you'll notice, is connected to D. And it is also connected by 2 loops. Now, if one loop counts as 2, then 2 loops obviously counts as 4. So these ones are zeros, and that is our adjacency matrix for the graph that we've just gone through. This time, our adjacency matrix is filled in. So we're going to make a graph from this. What we need to start with, there are 5 vertices. We have to do just make 5. 4, 5, and we have to label them A, B, C, D, and E. Doesn't matter how you put them in your network, as long as you've labeled them and you've put plenty of space in there. So, reading from top to bottom and obviously left to right like a book, as we said, A is connected to B once and C twice. So we have to go 1 line there and 2 lines there. B is connected to A once, already done, and it's also connected to itself, so with a 2, so we know that that is a loop. Then it's connected to C and to D. So B is connected to C, and it's also connected to D. Now we could go through the middle, or we can go around the outside. It doesn't matter, as long as they are connected. I'd rather probably go around the outside. C is connected to A twice. That's already done. It's connected to B. That's already done. And it's also connected to D. So we can put that in there. D is connected to B, which we've already done. It's connected to C, which is already there, and it's also connected to E. And then you'll see that E is only connected to D. So this is the matrix representation for this graph.